I guess one way of putting it is a side project gone slightly wrong. So I was like, okay, the package has been deleted. Let me wget the code. Had a look and I found AWS keys, so an access key and a secret key. Why is this possible? How many keys are there in PyPi? Like, this kind of got me thinking. So I built a project to scan every release using grep, some dodgy regular expressions, and it would like find live keys that have been uploaded, and then it would commit those to GitHub. And the idea was, you commit a key, that key then gets committed as an individual file, and then GitHub will scan that file, and it will say there's a key here, and it will then notify the user, and then the key will be quarantined by AWS, right?
That was today's guest, Tom Forbes, explaining how his side project went a little astray. A while ago, Tom wanted to dive deeper into some of the data that he could pull out from Python's most popular package manager, PyPi. Frustrated by the limitations of the PyPi API, he decided to take the information for himself and put it basically into a Git repository that would enable him to query the data more efficiently and be able to pull more information from the metadata. But there was a problem because Tom realized something strange was happening when someone made a pull request randomly asking for some data to be removed from his repository. When he investigated further, he actually realized there was live AWS credentials in that package, which coincidentally wasn't even the reason why the person wanted to remove it in the first place, but we get to that later. Tom got curious and wanted to see how many AWS credentials he could actually find in PyPi packages. And what he found was really shocking, but probably not unsurprising for those that may listen to this podcast a lot. So today we're going to sit down with Tom. We ask him all about his research and his side project, and we dive into what he found after scanning PyPi packages and how much sensitive information is actually out there. We also discuss why sensitive information gets added into these packages and what organizations can do to protect themselves. So without further ado, here's today's episode with the legendary Tom Forbes.
So Tom, you've been looking at the PyPi project overall as a project just to try to get some meaningful stats out of it and try to get a sense of the whole project. Why don't you tell us just from a high level overview what your project's all about?
Yeah, sure. I guess one way of putting it is a side project gone slightly wrong. It kind of grew from an initial thing into what it currently is. So the PyPi project is like the global Python package repository. So it's the default place where all Python packages get published to. It's been going since 2005, I think, is the first entry in the database. I don't know if there was something more before that, but that's kind of when it started. And there's about 8.7 million individual releases across 500,000 projects, which makes it I think it's the third largest package repository in the world, behind Maven for Java, which is a kind of similar size. And then there's the first one is obviously JavaScript's NPM, which is like 2.7 million packages or something like that. So it's pretty big in terms of the number of packages. And the project is called PyPi Data. And there are like two main sort of aims for the project. The first one is to mirror all of the code published to PyPi, historical and future, into GitHub. And the second one is to provide some tools to allow people to use this data in some way. That's the kind of too long didn't read for the project.
Yeah, really cool. I'm seeing so many similarities here between kind of the side project go wrong is actually exactly how GitGuardian started to bit of a side project that's gone wrong. But what inspired this original side project? What inspired kind of you to start working on this? What was the original? You said that to allow people to kind of understand data a bit more around this, but what was the underlying kind of reasoning behind that? What were you trying to give people to get out of it?
So this all started. Okay, so I guess it really started when I was doing something, I can't remember what, about 3 years ago or something, and I wanted to look at all of the metadata. So PyPi has like a JSON API that returns information about packages, etc. And I wanted to get all of that data, and I wanted to do something with it. But the API has it's not fantastic. It takes a lot of effort to sort of do this across all the releases. You have to make 10 million individual requests, etc. So I built a project that would do this and commit all of the JSON responses as text into GitHub. that means in the future, and as a SQLite file, sort of bundled up. So if I want to do something in the future, I wouldn't have to go and do all of this. The data's kind of just there. And I forgot what I was doing. I can't remember if I did it. I think it just turned into doing that. And I forgot about that project until about a year ago when I got a pull request from a guy who worked in Infosys. And the pull request was weird. It just had like nonsense. It was just like his cat stood on the keyboard. It was a bunch of stuff. He added 2 comments and then closed the pull request. And I was like, okay, this is weird. Looked at what he was modifying, and he was deleting a package, like the information, the JSON response for one of the packages. So I was like, okay, bit weird. I downloaded the URL. So PyPi doesn't delete any of the package data after you delete a package on PyPi. So you can delete the logical package, like the database entry, but then the actual artifact is still available. So I was like, okay, the package has been deleted. Let me wget the code. Had a look, and I found AWS keys, so an access key and a secret key. That actually wasn't why he was removing it. He removed it apparently because it had an internal URL in the metadata. So it's like their internal GitLab or GitHub server was in the URL. That was why he was removing it. It was pure luck that there was a code, a keys in there. So, I was like, okay, this is a bit weird, right? Like, how many keys? Like, why is this possible? How many keys are there in PyPi? Like, this kind of got me thinking. So I built a project to scan every release using rip grep, some dodgy regular expressions, and it would like find live keys that have been uploaded, and then it would commit those to GitHub. And the idea was, you commit a key, that key then gets committed as an individual file, and then GitHub will scan that file, and it will say there's a key here, and it will then notify the user, and then the key will be quarantined by AWS, right? So it's kind of like a slightly sketchy pipeline there, which allows you to scan for new keys. And I found a lot more than I was expecting. Like, there's a lot of keys in PyPi. People like publishing them. So then I was like, okay, fine, that's cool. But what about other keys? What about GCP keys or other credentials? It was quite a lot of effort to build the regular expressions to find the AWS keys without too many matches. Screw doing that for all of the different kind of things. Is there a service out there that does this? GitGuardian was one. GitHub is another. There's a few of them. Okay, what's the kind of common interface? Can I just send the packages there? No, it's Git. So why don't we commit all the code to GitHub? Which sounded crazy at first, but it seems to be working.
Yeah, that is really cool. There's so many similarities between this and how GitGuardian started. I want to give you I want to give you the quick overview of how GitGuardian started, because I think you'll find it funny. It started by our 2 co-founders who were working on a little bit of a project, and they discovered that GitHub had a public events API. So you go to api.github.com/events, and you get everything that's a ledger of everything that's happening publicly. And then they similarly wanted to try and make backups of this data so that they could do interesting things with it or understand what's happening so that they had more control. And then they discovered that actually, there was some keys being committed in here. Oh, there's quite a lot of keys being committed in here. And that is kind of like how it all, and then it was like, who's doing something about this? And then at that time, no one. So it's kind of like interesting how this all kind of unfolded and how it happened. But it is a very similar kind of approach of when you start digging into something, you really uncover a whole lot of unexpected things.
Yeah, for sure. And it's also the best kind of problem, right? This was a side project, and I'm thinking, I'm giving a talk kind of on the joy of coding and side projects in general. And quite a few people start side projects with like an idea in mind, like I want to learn React, or I want to do this, or I want to get something. But that's the wrong way of doing it, right? Like, you should start with a why question, or some kind of exploratory thing, and then see where it goes. Just as I had no idea that the PyPi JSON sort of thing that I built would enable this kind of thing or lead on to this. You shouldn't think too hard about what you do and see where it goes, right? And sometimes it goes to founding a company, apparently, or starting GitGuardian.
Yeah, sometimes. Curious I'm curious if there's been any data that just surprised you and you had no idea, like, wow, this is shocking? Aside from the fact you're finding actual keys in there, that should be shocking for everyone. We know we're always surprised by the number we find out in public GitHub from our State of Secret Sprawl report that put out every year. Like last year, 10 million. The year before that, 6.5 million. So that's shocking in and of itself. But I'm curious, what other surprising information did you uncover in this project?
There's twofold. The first one is like human behavior, I think. So the most surprising thing initially that I found was so this is with the sort of MVP, I guess, one that scanned just AWS keys. There was one package that someone was publishing, and they really, really did not like the automatic kind of AWS revocation, right? So they had the keys in plain text, and then sort of as a local variable or whatever. They would be scanned, they would publish a new release, and they were like, okay, I got an email being quarantined. That's not good. So they went through this kind of thing where they were trying to work out how to hide the keys in the code. And eventually a couple of times I did kind of adjust the regular expressions and some of the stuff to detect these instances. And eventually what they ended up doing was they replaced the keys rather than have them as hard-coded in the code. They had them as a GIST, a public GIST, and then the code would like fetch those from the URL and then use those credentials to access S3, I think it was. So it's like, I don't know, on one hand, the human behavior, like I really, really want to commit keys to GitHub, and I don't like these emails telling me that I shouldn't. I think I'm just going to do it, is one side of things. And FYI, if you do have a legitimate reason for it, you can just like ignore the emails or quarantine them or tell AWS that this is fine. And keys by themselves are not bad, right? If you have a policy that says the key can't do anything, then there's no necessary issue with having the keys out there, right? So it all depends on the context.
That's the exact nature of honey tokens. Is they're AWS keys that literally grant no permissions. They don't encrypt anything. So yeah, you can have those out in public, but they're going to get hit and you're going to get those alerts.
But yes, the first one was like surprising. Like some people really wanted to do this, and they weren't happy with me finding them. So that was the first thing. The second thing is, well, there's obviously like the big ticket things which are finding stuff. So one of the ones I've been sort of eyeballing some of the results that we've got. There's one company, I think, or one package in there which someone has committed I think it's like a README file for an internal thing that shouldn't be published. So every single version, Python packages have, let's say Django, right? There's Django version, and there are multiple releases. There's a source release, and then there's like one or more wheel releases. In theory, those should be identical. The contents should be identical. But there are cases where it's not. So in this case, there was one package that had in the wheel release, there was one README file and an extra directory. And that had like 400 OpenAI keys in there, just as one gigantic kind of thing. So they were kind of using this as some kind of internal wiki or something, and they committed that. So that's the kind of like, that was the most surprising big thing. There's also database credentials that I found for like Postgres instances, like live ones. There's all kinds of like fairly sketchy things. There's a lot of packages out there that have been published by accident. So I've got a fair few emails from companies, some more polite than others, who have found out that they have code on there that shouldn't be there. And what's surprising for that was some of these companies don't really understand what that means. I'm sure you've experienced this before as well, but they kind of email like, you take these tokens down. These are private passwords. And I'm like, okay, cool, but you should revoke them.
Would never. Yeah, I could feel your pain because like people, we have this trouble too. Like we will, if you leak a key and we find it, we'll try and email you and let you know that you've done that, for free. And then some people are kind of like, well, I didn't give you the right to look at my code. It's like it's literally public. You gave everyone the right to look at your code. It's in the terms and conditions. It's broadcast everywhere. And I'm letting you know that something bad's happened, and then you're like mad at me about it.
Yes, exactly.
But anyway, I find this so funny. Well, one question that I have is that we understand very intimately, at Git Guardian, how keys end up inside Git repositories, and that's its own kind of little beast, because you might have a developer working on a feature branch that commits something, removes it later on, and doesn't understand that history is going to live forever and that its keys are going to be in there. So that's one thing, but when you think about having like a PyPi package, a finished product, you would think that like, okay, surely we wouldn't have keys in there. Why from your experience, why does that happen? And maybe if someone's wondering, like, what is the correct way to be able to handle secrets when you're doing a package?
That's a fantastic question. So this is the next phase of the project, is to really try and dig out and get some numbers, some concrete numbers on this. Part of the project is committing the code, and part of the project is creating like an index, a big data set. Not all of the code can be committed, so we don't commit all the binary files, for example. And there are some very, very large files that don't make sense. They're text, but they don't make sense to commit to Git. Regardless of that, we have a bunch of Parquet files that form a data set with the contents and hashes, etc., of every single file within every single package. So the idea that I have is to sort of crunch these numbers and have a look and correlate those with some of the secrets that might have been found, and maybe derive some insights. But off the top of my head, from like eyeballing and my general feeling, there's a couple of main cases. The first one is Python tooling is not fantastic for packaging, which might be a controversial statement or not to anyone that's ever used it. There's a million ways to do things. There's various tools and various ways of publishing them. But one of the key things is there's no real standardized way for excluding things, right? Setup.py or the way you publish things generally don't look at git ignores, for example. So like a fair few of the issues that I found have been like people just having files in the source directory for whatever reason, like PyPi tokens. Maybe they've failed to publish something and they've copied the token file into the local directory to see if that works. And it works, but it's published the token as well. Accidentally committed files at some point. One of the things I found was Amazon themselves. So Amazon, one of the packages for the Amazon Pay SDK had one test file, like an integration test, that was not present in all the other ones that use a live key. So they had this kind of unique test file that they weren't meant to commit, and they had a bunch of working comments and stuff commented out, but that was just bundled for whatever reason when it was published. I guess they weren't using a CI system to publish it. But it sort of accidental leakage is through the developer, because the tooling doesn't allow you to easily ignore things or only include Python files, right? It kind of just bundles up a directory, which is annoying and very hard to sort of fix, especially when you've got a bunch of legacy stuff. The other side is people side of things. So Python is obviously gigantic with machine learning. There's a lot of machine learning packages in the ecosystem, a large percentage. So TensorFlow is 15% of all Python data or PyPi data. So it's a big thing. That's just one machine learning library. And a lot of practitioners publish internal stuff, and they're not software developers, right? They kind of just publish things. So the tooling is quite hard to configure. They don't have necessarily experience, the time, or the inclination to deal with it. They want it to work. So they kind of stuff slips in. But also what they're publishing, they just want things to work. So a lot of the stuff that I found, especially AWS keys, are like, I just want to download something from a bucket, right? There's some CSVs or something there for this model that I'm training, and here's a key for lab and access. I'll just shove it in here and it works. Screw it, publish it. So it's not understanding the concept of just why these are bad, combined with the tooling, I think is the general idea.
It's hard. It's tricky right now. So is there any recommendations, if there's anybody working on the PyPi project itself right now, any recommendations that you think could make that process easier? Or are there specific things that someone working on that, like, hey, heads up, this is what you should know going in, that's going to make your life easier?
Yeah, so there's two sides of things. There's the Python Packaging Authority, which publishes sort of standards for how we actually distribute Python code. And then there's this sort of PyPi server team, the people who maintain PyPi and include the code and the kind of reference implementation, I guess, of how a package repository should work. For the PyPi server side of things, it would be really, the most immediate thing would be to have a way of just blocking uploads that are clearly internal, right? So every Python has to have a license. We could add an internal license of some description, right? And any upload that has an internal license, PyPi just says no. Like, you have an internal license. This is an accident. Because it's quite easy to, PyPi is the default publishing place. So, you could have the company I work for has a big Django monolith. I could fat finger something with some credentials and publish that to PyPi, like, very easily, right? It's one mistake away from a very bad day. If you had some way of just saying, this is an internal package, it should never be published to PyPi, and if PyPi was to block that upload before it was ingested, I think that would be quite a simple thing, and it would stop a fair few issues. on the actual packaging side, on the sort of distribution side of things, like just having a better way of not including tokens, I guess. I mean, clearly, if there's a file in your root directory called PyPi token or PyPi IRC, whatever it's called, I don't think you ever want to bundle that. Like smarter things around, smarter defaults around what to include in packages and what not to include, and maybe early exiting rather than just like assuming it's fine and publishing. If it looks sketchy, ask the user in some way and say like, update this file. Like, I'm not going to publish this. It could contain rubbish. If you're really sure, you hit the red button, press yes twice, whatever. Otherwise, I'm going to bail out and err on the side of caution.
There was a way you could use a tool in your Git pre-commit Git hook to stop you from adding things like credentials. I don't know.
Is this the plug?
Or something. Yeah.
Oh, yeah. GG Shield? Was that what you'd call it, would you?
That's what I'd call it. Yeah, that's arterial, obviously, for that. But it touches on a bigger issue that this is a very confusing subject, and I mean packaging in general. Having tools like maybe that's a good solution, is like maybe a pre-packaged checker. Like, I'm gonna push, like, add it to the pre-push step. Like, hey, let's do a last check on this thing before it leaves my local machine. Let's make sure we did it right.
So there's that's a really good idea. I like that idea a lot. The issue is, there's always the human side of things. So I mean, there are a lot of the credentials that I've currently they've been flagged are kind of test credentials. So a large portion, obviously, are like RSA private keys and test files, etc. So whatever tooling we have around this, if we do improve it in some way, it needs to be selective, right? Otherwise, okay, just press yes, okay, ignore this warning, just press yes and publish. You need to kind of make it as user-friendly as possible while excluding the false positives as much as possible, right? No one wants to be blocked by something that they don't think is an issue. And if you display some kind of big old list of secrets and most of them are tests, you miss that one which is like super secret key for DNS servers, screw it, publish. So but there's a slightly different kind of model for secrets in code in packages versus secrets kind of in Git repositories, in the active development branches, I think. But if you can nail that, that's a fantastic plugin that you can have for pip or poetry or something like this, just a pre-check before any kind of commit.
Yeah, I mean, it's an interesting thing, and it's the trouble with security too is that the concept of alert fatigue is really real, and and then you have to weigh up: do you want a high precision? Well, you want a high precision, high recall, but is that a reality? And then which one are you willing to give up more control of? Do you want to let a couple real positives slip through for the sake of the tool being useful, or are we going to stop on everything and investigate it? Do we have the capacity to do it? So this is the real challenge with it. And the one thing that I think that is potentially could change this is that secrets detection, and I think we can extrapolate this to all levels of other niche security events. It's all getting so much better. And as we're starting to leverage more and more AI and machine learning, I think that we'll be able to solve this to a point where false positives become less of an issue. But the challenge is we're not there yet. And this is a problem now, right? As you've clearly outlined.
There's also a distribution problem. So, I mean, if we have this kind of system that tells you 100% of the time, if there is a secret, amazing, fantastic. The intersection between people that publish secrets willingly, unknowingly, whatever, and people who know enough about it to use the tool are, not gigantic. So it has to be by default in some way, or, it has to be bundled with pip or something, and that's a whole kettle of fish, right? Although one interesting idea that I had would be, because there's also the issue with, I mean, when you publish a package to PyPi, it's live immediately. There's no kind of approval process. There's no kind of are you sure at the server side, right? So, I mean, genuinely, you can publish an internal package without even realizing it, and then it's just live, and you forget about it, and you don't realize, etc. It'd be interesting to have, I mean, you could do this as a PyPi proxy, right? You could publish a package to GitGuardian. You have a UI for scanning it. You have a UI for approving it, release, or et cetera, for companies. And then you press yes, and then you guys publish that to PyPi as some kind of proxy, right? Like a staging area, right? That's interesting, something like that. That would work as kind of intermediate and allow you to scan things without having to integrate with pip and having a client-side checks versus PyPi integrations.
Yeah. I mean, it's definitely very interesting. From your perspective, if you could nail down a couple of, like, from everything that you've seen, I'm sure you've seen a lot of kind of human issues that keep coming up. If you could give some advice to maybe organizations or businesses, what around securing these packages, what do you reckon would be something simple or that they could do? Maybe not that simple, but something really important that they could do that would actually improve security based on what is already existing, what's available now?
Oh, that's really hard. I don't think there is. Okay, so it has to be retroactive, I think, is the issue. So if you don't have a lockdown corporate machine, I could have my personal PyPi login. Maybe I'll publish an internal package, or I maintain a package for big corp or whatever. I publish that to PyPi. Don't have a CI system. So obviously, the first one is like having a CI system to publish things automated. Don't have credentials for big corp on local machines. Pretty obvious. But then I could just use my credentials to publish your code, assuming PyPi doesn't have a kind of restriction on this. So there's no way to stop sort of accidental leakages like this. You just have to be retroactive. So one of the best ways is to look at metadata. So internal URL in the homepage of a package, big flag. And that's how most of the reports that I've had for internal stuff, that's how they find them. They scan GitHub, they look for internal Apple had one, internal.apple.github or whatever, find that string anywhere in any metadata. That should not be there. That's an internal package that's been linked. So retroactive, I think, is the way, and having a standard way of standard identifiers for all of your packages. So make sure all the packages are prefixed with a company name, for example. PyPi doesn't support name spacing, so you can't have like npm style at Tom Forbes /foo. They're all global. If you have an internal policy that says all packages should be named company name underscore, so I don't know, Octopus Energy underscore foo or whatever, Git Guardian underscore XYZ, then you can look at the set of all packages that have been named like this. And if there's one that's clearly not there, you can contact PyPi, get them to take it down ASAP, or look at what's there, rotate the credentials, etc., etc., etc. But I mean, with regards to like, there's nothing that you can do based on the current Python packaging model to say restrict everything, right? Lock it down. A corporate firewall maybe on all your machines and block PyPi upload access, block all put requests to PyPi.
Yeah. Well, I mean, this is what people are trying to do with things like OpenAI, and blocking it. And then all you're doing is you're annoying people and you're sending them into they're doing it in ways that it's undiscoverable, which makes the whole situation even harder to discover and harder to. So yeah. Great, rosy, cheery answer. What could you do? Nothing.
Is lobby your local Python representative to try and improve the process, maybe. I mean, it's pretty standard, right? And if enough people, this project is to bring some numbers behind some of the discussions. How many of these packages are leaked by accident? How many can take credentials? Using these numbers, you can make a bit more of a case for making changes or potentially breaking changes or making improvements to this process. Well, one thing you can do as Mr. Corporation is to, if you do find a leaked package, don't send angry emails to the person that is helping you find them. Number one, I think. Don't threaten to sue them either. That's not very nice. And rotate the keys immediately, obviously. Don't imply that by deleting the code, the keys are now not private. Interestingly enough, talking about licenses, you mentioned before, when you upload code to PyPi, you agree to the terms and conditions for uploading them. You grant PyPi license to your code to mirror it, etc. You also agree that the code is not private. You agree that this code is not internal, it's not sensitive. So I mean, legally, if you published it, it's out there, right?
Yeah. Well, I mean, and like, do you want a good guy to find it that's going to alert you, or because other people have, and this is what we demonstrated with leaking stuff on GitHub. And what is really fun to do is that you can create a honey token, which basically gives you information about the type of, lets you know when someone's trying to exploit an AWS key, lets you know their IP address and all of that. And then what's really fun is that you can actually watch this, how it happens. First, a bunch of bots will try and find it. and check that it's valid. Then you'll get a spike of activity. Then nothing will happen, and then you'll get a secondary spike of activity weeks later, and that's when basically that credentials end up being sold as part of the package on a dark web forum. And then you can watch it, and then the calls change, because the calls that you get at the start are like get caller ID, basically, like, is this valid? And then the ones you're going to try and do is kind of going to be trying to apply policy changes to the accounts. So it's really interesting. So don't get mad at the guy that's trying to outline the problems, is basically what I'm saying, because there's plenty of malicious people that will be doing it without you knowing.
We always like to ask all our guests a couple specific questions. We turn into kind of a game show here. What's the absolute best advice you've ever been given about security, or you feel needs to be given about security? And then the opposite of that, what's the worst advice you've ever gotten, or advice you've read somewhere that was like, what are they talking about?
The worst advice for security that I've heard, I was doing an application test for a healthcare provider, and it was a .NET local application, decompiled it. There was just database credentials in there. So what it would do was it would have an API endpoint, but the API endpoint accepted the database credentials from the client, which is like just the weirdest way of doing anything. So the client would have these credentials and it would send the username and password every request to the API endpoint and say, fetch me this. And it would return the healthcare data for people. No access controls, direct connections to the database, et cetera, et cetera, et cetera. The client told us that it was illegal to decompile it, so therefore it's safe. Which
that's going to stop the criminals. Yeah,
you nailed it. Yeah, you were straight. That is the worst. That is the worst one I've ever actually legitimately heard.
That was a non-technical person to begin with. It's illegal. I mean, they're not going to do that. We did make it very clear in the report that is not a safe one.
Wow. Wow.
Oh, well, why have locks on my door? Why have an alarm system in? It's illegal to break in anyway, so why would anyone do that? It's against the law.
The best security advice, or maybe the best advice that I would give, I don't know if anyone's given me this specifically, maybe it's an amalgamation of all these sort of advice that I've heard. It's like, you should always think as an attacker, right? You should think about how your system is used. You should think about, in the same way that you should validate, if you're a backend developer, you have a username field or an email field, etc. You validate the username is an email, for example, right? You don't just trust the client. A lot of people don't think in this mindset. It seems fairly obvious to a developer that you should do this, but they don't think one step ahead, which is like, okay, I receive an integer from a primary key from the client. Maybe I just use that directly, fetch the model, and return the result. Do I check if that model is associated with the user that's requesting it? If there's some permission chain there? Some people don't. The best way to think about this is always think, for every endpoint, everything you're building, always think, or have it in the back of your mind, how would I screw this up? What happens if I put a number in there? What happens if I put someone else's ID in there? Like something like this, right? Always have the mindset of how can I break this? And I think you end up coming up with better systems, better designs, better, more secure things.
I really like that. How can I break this? How could I break into my own app?
Yeah.
I don't think I've ever asked myself that question building anything. Like, how would I hack my own sites?
I mean, following on from this, the best advice actually is not to do that. It's to use a framework that takes care of that for you. So if you don't, you shouldn't have to think about that, right? You should have a library or Django, for example. I work a lot with Django. Use libraries, build things internally that means you don't have to care about this. You only care about it when you're doing something really weird, right? So you're doing something very strange, something that bypasses something. And don't write your own validation logic. Reuse as much as possible when it comes to security. And don't write your own crypto as well. I think that's the brain dump of all of my security advice.
No, that was awesome. I think that's making the highlight reel for sure.
Awesome.
Well, listen, thanks so much for taking the time to sit down and chat with us. It's been really interesting and fascinating to hear your insights. I really hope that we can have you back after you've taken the project further, and we can discuss other things that you've managed to find as this unfolds. But thanks for creating this side project. These things take time, and the community really appreciates it. So I hope that you continue, and I hope that people appreciate it, and amongst the people that are complaining about about what you're doing.
Thank you.
Dwayne, any final words before we hang up?
So for people that do want to follow your progress and follow this, where's the best place they can track all this work?
Yeah, you can follow me. I don't have Twitter or Instagram or anything like this, but you can follow me on my blog, which is tomforbes.es. And I will be blogging about this or sharing it. There's also the repository itself, the organization. So that's github.com/pypi-data. There will be a sort of README there and some links to the actual site, and you can explore the data for yourself and use some of the tooling. Maybe you have some ideas around the data, what you can do with it. Hopefully it helps. And feel free to email me at the email address on my blog or on my GitHub profile if you have any questions.